Good afternoon. In this part of the core workshop, we are going to cover 20 million years of sedimentation in the lower Cretaceous upper Permian to lower Albian is shown in the core. This is an interesting chord section as it contains 3 oceanic anoxic events, or OAEs. Please note my co-authors, as this is a multidisciplinary project. I specifically want to mention David Hall and Ryan Phelps, who are former students who worked on the stratigraphic section. Also, I want to mention my approach to this core presentation. I am not going to show long sections of the core. I prefer to show details of representative core slabs. I like this method as I can get across more detailed ideas about the features within the core. If you are interested in seeing photographs of the complete core, let us know and we can get them to you. Finally, I will break the presentation into several parts so that we can have several chances for questions and discussions. This core is significant because it can serve as a tight chord section for the Sligo through the lower Odessa or Glen Rose in the up-dip subsurface in South Texas. The section contains the lower Cretaceous OAE 1A, regional OAE, and OAE 1B zones. OAEs are important as they affect both reservoirs and source rocks. Let me note here that the emphasis on the core today will be lithofacies and associated sedimentology. The details of the OAE will be presented later this week. These details include XRF and Hawk analyses. This core also displays the sedimentology of several unconventional and conventional targets. This is an isopack map of the Pearsall Formation in South Texas. First, it shows the location of the Tentacle #1A well, right here. This well was part of an ambitious exploration program by Tentacle back in the late 60s to early 70s. Tentacle drilled at least 30 wells in the area, out through here, and cored many of them. Unfortunately, they did not find commercial oil, but they did encounter some good shows of oil. I think the problem for exploration in this area is that there are no good up-dip seals as the area is highly faulted. The map also shows the general morphological features present during the sedimentation of the chord section. In South Texas, here is a Maverick Basin, a long-lived basin. Here is the San Marcos Arch, a high area separating South Texas, Maverick Basin from the East Texas Basin over here. Oh, and this is where the Sligo Reef Trend was located during Permian time. Ryan Phelps and his co-authors published in AEPG in 2013 a detailed analysis of the stratigraphy of the lower into the upper Cretaceous. They also define the composite sequence for this section. These are located along the axis here. Note that these sequences contain several third-order sequences. These are composite sequences shown here, and they can have third-order sequences in them. In general, the Sligo section had an active reef platform margin and a broad platform behind it. Here's the active margin. Finally, at the end, it starts to retrograde back during the deepening in Pearsall time. During the time of the Pine Island shale and up into the lower Odessa, the platform transformed into a ramp where there was no shelf margin reef. So from here up through here is a ramp setting on a drowned platform. No reef margins out here. Not until the upper Glen Rose did a shelf margin platform reef initiate again. It's showing here. The Glen Rose just prorated out and then it graded up during more of the Edwards time. So this is the Stewart City reef margin trend. The yellow box shows a stratigraphic section displayed by the NA core. Also, the three OAEs are noted. The OAE 1A in the upper Pine Island Shale through the lower part of the lower Cow Creek. The regional OA is mainly in the lower Bear Shale. And the OAE 1B starts in the uppermost Bear Shale and goes into the lower Odessa. In this slide, we see the wireline log for the #1 NA well with log picks. In here, here's the Sligo. This would be the Pearsall through here, and the Odessa or Glen Rose up through here. Inside here, we have the Pine Island, the Cow Creek, and the Bear Shale members. To the upper left are to the left are composite sequences of Phelpsonol 213. Composite sequences, and remember inside of here there are third order sequences. Overprinted on the wireline log are the three OAEs as shown by the light blue. OAE 1A, regional, and 1B. We will revisit this figure many more times during this presentation. This is the core description of the complete NA core. It is 529 feet long. The core to Sligo up into the Odessa or lower Glen Rose. Here would be the Sligo section being carbonate rich, Pearsall, shale, the lower Bear going into, the lower Cow Creek going into the upper Cow Creek. The upper Cow Creek's a really well-developed high-energy limestone. Going through the Bear section, mixtures of carbonates and siliciclastic. Then in the lower Glen Rose, you go into some carbonates, but a lot more siliciclastic rich mudstones. Again, I'll be showing this description in detail during this core discussion. I want to use this slide to introduce oceanic and oxic events, or again, OAEs. I'm sure many of you are familiar with these events, but if not, I'll try to quickly give you a few facts about them. Actually, I'm embarrassed to say that until I started investigating OAEs and reading up on them, I really didn't appreciate how complex they can be. First, for a general definition. OAEs are intervals in the Earth's past where portions of oceans become depleted in oxygen over large geographic areas. They are commonly associated with organic rich sediments such as black shales. However, in a NA well, this is not the case. The OAE itself is characterized by the sequestration of light carbon or carbon-12. OAEs are best developed in basinal environments, but note in our situation here, we are on a ramp that developed on a drowned platform. And the OAEs are commonly defined by carbon isotope curves, either organic carbon isotopes or carbonate carbon isotopes. In this investigation, we found that carbonate carbon isotopes show the OAEs quite well. And that's what we show here is the isotope curve plotting the delta C13 against depth in feet. So this is an example, part of carbonate carbon isotope, carbonate carbon isotope curve to a complete isotope cycle associated with an OAE. First, I've divided the cycle into 4 stages: the non-OAE, the pre-OAE, the OAE proper, and then the recovery zone or recovery interval. We see these components, each of the 3 OAE in the NA core. Okay. The non-OAE is a stratigraphic section where sediments were deposited in normal marine waters. There's a time when the oceans were not affected by the pre-OAE or OAE proper. Now this is the non-OAE isotope curve 2 here. Here's the pre-OAE. It is evidenced by an increase in carbon 12 or light carbon, increase in light carbon, and may be related to volcanism, rapid seafloor spreading, and or large igneous provinces. Now the OAE proper, it is evidenced by an increase in heavy carbon or carbon 13 and is related to overproductivity and associated anoxia. Example is from upwelling. And here you can see C13 or the heavy carbon increasing. Then above that is a recovery zone or the post-OAE where the ocean returned to normal marine waters. I will go through each of these stages in detail through this core presentation. Okay. And this slide shows the full isotope curve through the NA core, along with the core description and the HAWC TLC data. Here's the isotope curve, description, and HAWC TLC data. The HAWC analysis will be discussed in more detail later this week. I'll just give an introduction to it now, but not mention it again through the talk. The OAE intervals are again marked, 1A, regional, 1B. Again, this isotope curve is from David Hall's master thesis research. And in here, the OAE1 clearly stands out. That's the zone through here. There you got heavy carbon increasing up through here. The regional OAE and OAE1B are also present. This is the regional OAE, the heavy carbon increasing, and here's a OAE1B, again, the heavy carbonate increasing. These C notations, as you've seen here, here, going up the thing, are labels for parts of the Aptian-Albian isotope curve and were first defined by Mengadi in all 1998 and extended up section by Browlower in all 1999. It's very interesting. These C segments are recognized worldwide. I'll show you some slides on that this coming week. Also notice that this core section has no highly organic rich black shale commonly associated with well-developed OAEs. Okay, before I leave this slide, a word relative to the TLC plot over here. Here's TLC percentage, and then obviously depth. There's 0 to 2.5. The red lines segment this graph into 0.5% intervals. Remember that in a carbonate, just 0.5% TLC makes a fair source rock. So anything right of this first red line is a potential to be a source rock. And also anything past that line to get that much TLC deposit, it must mean you're in ideally a disaerobic or anaerobic environment. And note there are only a few zones in here that have a little bit of higher TLC, and they're sporadic going up through this section. And on Thursday, I'll try to relate these more back to the stages of the OAEs. But much of the section through here have low TLC values of 0.3% or less. These lower values are in deposition during a normal anaerobic environmental setting. An example would be, good one is the Upper Cow Creek here. Notice how low these are, 0.3, possibly 0.4. This is your normal aerobic or oxic environment, low TLC. This slide just lets you know that we did a full suite of handheld XRF analysis on an A core. This XRF analysis provided analysis for 30 elements. We show analysis of 8 elements in this figure through here that can be used as proxies for minerals or environmental conditions. These analyses will be discussed in detail later this week in our presentation on the emphasis on the OAEs themselves in the NA core. I think this is the end of the first part of the presentation.